Okay, everyone, welcome back to the webinar. Our next presenter is Lam Tran. He will be presenting Chapter 9 Stormwater Design Requirements, the updates for Part 2 of this Chapter 9 presentation. Take it away, Lam.
Thank you, Louis. My name is Lam Tran. I'm a supervising engineer for Stormwater Plan Review Section at the Houston Permitting Center. Following Ivy Wang's presentation on Chapter 9 updates, I'll continue with the latest stormwater design requirements for stormwater utility in the right-of-way. After that, I will present the remaining of the Chapter 9, which includes the stormwater quality design criteria, few miscellaneous, and introduce the Green Storm Infrastructure Program. I'll cover the remaining storm sewer design and then summarize the 5 different plan submittal types. Here are the updates. The City of Houston streamlined the use of different storm sewer pipe material to be used under the roadways. The IDM updates include design requirements for both thermoplastic and concrete pipes. Here in this presentation, I'll present mainly about the thermoplastic pipes. Under this IDM article, thermoplastic design requirements, it can be summarized by 3 points. 1, the engineer shall follow the national standard of AASHTO LRFD bridge design specification. 2, pipe cover requirements for plastic pipe having a minimum and a maximum cover. And lastly, the engineer must determine the suitability of thermoplastic pipes for their projects. For application of thermoplastic pipes, in this table 9.2 to the left, summarizes the backfill cover requirement for storm sewer and culvert pipes for different application. The table 9.2 outlined the different use of pipe at the different locations, including installation under a local street, major thoroughfare, or under a driveway, like a culvert. On the right, the detailed drawing shows the different heights of the cover that can be accounted. There are 2 types of roadway pavement. Flexible pavement is asphalt road, and then in green there on the right is rigid pavement, which is concrete road. For asphalt pavement, the cover is measured from the top of the pipe to the bottom of the asphalt pavement. For concrete pavement, the cover height is measured from the top of the thermoplastic pipe to the top of concrete pavement. Put it into perspective, considering the topography of the Houston area, it's flat and the pipe slope design can be a challenge. Therefore, having a rigid pavement over the pipe does have an advantage. The storm sewer can be more shallow or at a higher elevation for better gravity flow. Again, on the pavement type that is installed over the pipe, asphalt or concrete, the cover requirement is determined differently based on the table 9.2. Now, moving on to other criteria when designing drainage system in the right-of-way. Comparing the 2 tables, the city removed in 2023, for the 2023, the city removed 2 of the inlet types. And for 2026, we updated the storm sewer curb inlets to accommodate a wide range of drainage design. The 2 families of curb inlets are type BB inlet and type C inlet. Under each family, the different type inlets have different flow capacity. The city added table 9.3 to summarize the storm sewer pipe and culvert pipe material that can be used in the right-of-way. Particularly, polypropylene pipes are allowed to be installed under roadway or driveway culvert. Resilient connector or rubber gasket is required for connection to city storm sewer system. This new requirement, streamlining the different thermoplastic pipe application in the right-of-way, allow flexibility for engineers to design storm sewer system to be suitable for different types of projects. The city updated the design of culverts requirement to streamline the plan review approval. The updated requirement, such as maintenance and functionality of culverts, were considered. Covering the ditch is sometimes required when traffic requirements, such as roadway pavement widening or a combination of proposed right-of-way features that cannot be met to fit inside an existing right-of-way width. Roadside ditches design, the detail. The driveway with culvert detail sheet is updated to allow appropriate culvert end treatments other than head walls. For example, slope paving on or earthen slope protection is now included in the IDM. The cover requirement for RCP is the same. The cover requirement for thermoplastic, such as HDPE or polypropylene pipes, is illustrated in the detail drawing number 10G. Note that if the culvert end is extended for earthen slope, the spacing between the driveway will need to be wider than 8 feet. That concludes the stormwater design requirement updates. The city added the plan submittal requirement. Shown here is a summary for different plan set, drainage report, and stormwater quality permit application. The intent of section 9.7 submittals is to specify documents, drawing, calculations, forms, approvals, and digital data that must be submitted to Houston Permitting Center for review and approval for stormwater design, detention, drainage, and stormwater quality components of a project. It ensures consistent, complete, and verifiable stormwater submittals across BCE, OCE, and capital projects. The next half of the Chapter 9 update include the stormwater quality design requirements. Under the stormwater quality design section, we have two categories of best management practice, or BMP. First one is temporary BMP, or it's called SWIP, and permanent BMP. Let's go through the first one. SWIP stands for Stormwater Pollution Prevention Plan. Previously, in 2023 IDM, for site that is less than 1 acre, a general SWIP construction notes and SWIP detailed drawing was required. Now for 2026, any new development or redevelopment will require site-specific SWIP. The site-specific SWIP could be a standalone drawing or be incorporated into a typical overall site layout drawing, depending on the scope of work. The SWIP detail shows the most common types of BMP, or best management practice, and their respective installation requirements for inside the private property or in the right-of-way. The typical features that will reduce the pollutant-carrying runoff are reinforced filter fabric barrier, stabilized construction roadway, inlet protection barrier, and filter fabric barrier. Here's an example of a site-specific SWIP for OCE projects or in the right-of-way. For OCE projects to make public utility tie-in, for example, storm, water, or wastewater, a simple call-out of BMP to protect the public stormwater system can be incorporated into existing drawings. This drawing shows inlet protection barriers for during construction in the right-of-way. For BCE projects, this is where the most soil disturbance are made that would cause unwanted tracking of pollution into the street or create nuisance to public safety or having adverse environment impact that would ultimately impact the state and U.S. water. The SWIP will be required to identify the BMP features to be installed before vertical construction or site excavation is made. For example, in this illustration, the three common features that are implemented are reinforced filter fabric barrier, also known as sill fence, inlet protection barrier, and stabilized construction roadway. Now, moving on to the second category of the BMP, we'll look at the design requirement for permanent BMP, also known as stormwater quality feature, that will function as a stormwater treatment system after the site is developed, as defined by the stormwater quality permit. When designing for permanent BMP, two steps should be considered. This first step is site characterization. When the stormwater quality permit is required for your development, the engineer shall design a system to capture and treat the stormwater runoff before discharging into the city storm sewer system. For the design of stormwater quality features, the engineer shall characterize the site for potential pollutant. The IDM update specified the requirements for pollutant removal, such as floatable, sediments, hydrocarbon, and bacteria. Note that not all development will require bacteria removal consideration. For step 2, the engineer shall consider the minimum water quality volume to be treated before discharging. The city added the design criteria requiring a minimum of 1 inch of storm depth or volume of required treatment for both new development or redevelopment. Of that volume, the city required a minimum of 50% TSS removal and 60% of best achievable practice for bacteria removal, indicated by E. coli and enterococci. Moving on from the minimum stormwater quality design criteria, the city now includes stormwater quality feature design criteria to guide engineers for both conventional and LID technologies. The minimum design requirements, as stated on the previous slide, a minimum of 50% TSS removal, and this table will allow engineers to determine which technologies is suitable for the specific site. For example, under conventional technology, a large development such as commercial shopping complex or a warehouse could benefit from a centralized treatment system such as a dry or wet detention basin or hydrodynamic separator to remove floatable sediment and hydrocarbon. And on the right side there, under LID techniques, a large development such as a city center or a city park could benefit from various LID types to capture sediment and bacteria. This is an example of a dry detention basin that can be used as a stormwater quality feature. Within a typical detention basin, the grass slows down the flow and captures sediment, and any floatable will be captured by the trash rack located near the outfall. This type of feature can be designed with dual use. In the photos here, there's a playground located inside the dry detention basin. This is an example of a LID technique called green roof. This technique can be configured in different ways. This green roof at the Houston Permitting Center captures rainwater and pollutants from the downspouts and filter through the soil media, and then slowly release the absorbed rainwater into the storm sewer system. LID techniques can be implemented in conjunction with conventional stormwater quality features to provide a comprehensive best management practice for stormwater quality features. That concludes an overview and updates of stormwater quality design. Here's a miscellaneous. Like they say, a picture is worth 1,000 words. The city made improvements to the Chapter 9 by adding numerous figures to illustrate and streamline the design requirements. For example, we have about 15 figures of the LID techniques that can guide engineers to meet the city's requirement. Few other notable figures are the 9.8 to 910, which clarifies the detention exemption for projects within the approved location, such as Central Business District, Texas Medical Center, and Lower Buffalo Bayou. The next presentation after me will expand on the GSI program, specifically on LID guidance manual. For now, I will briefly introduce the permitting component for the Green Stormwater Infrastructure program. Table 9.11 provides a summary of LID techniques, which includes the stormwater quality treatment features type and example application of the feature. The article numbering within the LID type column provides the location of the requirements within the chapter for each LID type. The table provides example of LID application, and it's useful for design engineers or architects. For example, numerous tree boxes can be installed along sidewalks in the dense urban area like Central Business District or downtown. Bioretention system can be installed at a different scale, from residential setting to parks and trailways to capture rainwater and pollutant. The LID incentives have been updated in the IDM. For detention reduction consideration, a preliminary meeting is required to demonstrate a conceptual design of the stormwater runoff for the proposed LID techniques. Typically, for a medium-sized project that is less than 20 acre, using one or more LID techniques can receive detention reduction up to 0.15 acre-feet per acre, and calculation must be provided to sufficiently mitigate stormwater runoff. Also, incorporating GSI may qualify your projects for the tax abatement through the Mayor's Economic Development Group. Another incentive is expedited plan review, and the applicant shall label the plan set as green stormwater infrastructure. That concludes the storm sewer design and stormwater quality design requirement. So it's time for question and answer. Hussein, do we have questions?
Yes, thank you, Lam, for the presentation. Let me go over to some questions we have. I see here. So first question, if the design engineer wants to use thermoplastic pipes such as polypropylene or HDPE on the roadway, what type of joint is required?
Thank you, Hussein. So for thermoplastic, we require that resilient connector or rubber boots gasket shall be used to make a watertight connection.
Okay, thank you. And the next question, what's the update requirement for stormwater quality devices such as hydrodynamic separators or inlet filter baskets?
So the devices now, the design requirement, you have to treat a minimum of 1 inch storm depth, which is increased from a previous of 0.5 inch requirement. And one of the criteria you have to consider is 50% TSS removal.
Okay, thank you. And the next question is there a requirement or consideration of groundwater table for HDPE pipe?
Yes, there is. Christopher, can you expand on this? I know you're probably the go-to person on this thing.
Yeah, I can assist, Lam. So my understanding the question is there a requirement or consideration of groundwater table for HDPE pipes? The short answer there is yes. The IDM states that buoyancy shall be a design consideration when specifying thermoplastic pipes.
All right, thank you.
Thank you, Chris. The next question is stormwater quality pollution prevention plan required only for commercial projects?
No, the new requirement, you have to have a SWIP now that details the selection of the devices for all projects, large or small, in the right-of-way or in BCE plans.
Oh, okay, thank you. Let me see. There's another question. Does the city allow long ground culvert or covering of the ditch?
Yeah, we updated this requirement here. There are instances where we do allow covering the ditch. So there are instances where traffic requirements, such as a left turning lane, a right turn lane, where they have to wind the roadway. In that cases, we would consider engineers to analyze the impact of the covering of the ditch before the approval.
Okay, thank you. And okay, next question. Can you confirm the previous I equals 0.27 inch per hour rainfall rate? I mean intensity, I think, or intensity of 0.27 inch per hour rainfall rate for stormwater quality design that is now updated with the BMP flow rate of 1 inch per hour minimum? Or will the BMP flow rate follow the Atlas 14 2-hour, 1-hour storm event?
Yeah, that's a good question. As far as the comparisons with the historical and new, the new information was vetted internally and externally here, and we can follow up with the comparison after this presentation.
Okay, thank you. We are short of the time. I hand over to Chris or Luis to introduce the next speaker.
Thank you, Sane. Presenting Chapter 9's LID updates and Green Stormwater Infrastructure Guidebook is Paresh Lad and Tanzim Chowdhury from Transportation and Drainage Operations, Stormwater Planning. Take it away, gentlemen.
Thank you, Luis. Before we begin, I'd like to introduce Councilmember Abby Kamen, who has been a strong supporter of our work on green stormwater infrastructure and the IDM updates for Chapter 9. Councilmember.
Thank you all so much. Can everyone hear me okay?
Yes, we can.
Great. Well, I want to thank you all. I think you've been going through this for a few hours now, but a few special thank yous to the department for hosting and sharing the highlights that you are going through, especially Luis, Garza, Paresh, of course, and Tanzim. What is it in Chapter 9, the addition of green stormwater infrastructure to the IDM has been years in the making. None of this would have been possible without our partnerships, specifically also in the private sector and education sector. But first, of course, Deputy City Engineer Joanna Clark and her entire team in Public Works, Rice University professors Phil Bedient and Richard Johnson for their work on the study that my office actually funded to inform the new language, specifically looking at the implementation of green roofs, which is one of several GSI methods that has been included and expanded upon in this year's IDM. And of course, Charlie Penland with Walter P. Moore has been instrumental in the development of the language that was added, including bioswales, permeable systems, and other sustainable solutions. And this is really important because not only are we talking about tools for each of you in your toolbox to account for drainage requirements, which we know is critical, I hope this will also allow you and others to utilize more square footage in your developments, increasing the value and the beautification of your projects and buildings, and save on energy costs in the long term. There's also this important overarching public benefit. As I said before, reducing flood risks and improving air and water quality and combating urban heat island effect. Some of you may know this, but with urban heat island effect, the surface temperature of green roofs alone can be 56 degrees lower than conventional roofs and can reduce surrounding area nearby temperatures by up to 20 degrees. So the added language that you're going to be going over is a really important step towards a more resilient and sustainable city. And my ask of all of you is that we continue to partner to incorporate these new tools that you all now have at your disposal. Again, none of this would have been possible without the hard work and collaboration of our partners. I'm very grateful. I welcome feedback, and I hope we can, again, continue to build on this as we create more tools in your toolbox that benefit you and our entire city. Now I will be passing it off, I believe, back to Paresh and Tanzim to discuss these changes.
Thank you, Councilmember. In an effort to promote low-impact development, green stormwater infrastructure, we've updated and added additional stormwater techniques, which encourage the use of natural features within a development. To complement these updates, we've also released our guidebook in developing and maintaining LID features. As we review LID techniques, we'll also reference the guidebook on details about the features and the best management practices for design, maintenance, and construction. Section 9.602 on page 259 and table 9.11 describe all of the LID techniques that are in the IDM. For our presentation today, we'll go into more details about these techniques and their uses. We'll also reference our GSI guidebook, which shares more details and benefits regarding the implementation, also operation maintenance of these systems. Our first technique is bioretention. This is a vegetated feature which provides stormwater quality benefits and can be designed for various storm events. It's designed for various sizes and storm events. They feature native plants and engineered soils for adaptability and drainage. A tree box is also a version of bioretention and are also typically used in right-of-way where spaces may be limited.
This concept refers to a shallow, landscaped area designed with natural features that replicate pre-development hydrological conditions. Its primary purpose is to capture and infiltrate stormwater directly on-site, reducing runoff and promoting groundwater recharge. Common application of this approach include rain gardens, tree boxes with engineered soil, tree trenches, and bioswales, all of which integrate vegetation and soil systems to manage water in a more suitable and natural way.
Infiltration trenches allow water to be temporarily stored and slowly infiltrate into the ground. This feature is typically not long and narrow, filled with stones and allow for storage between voids. This feature may also have an overflow feature to capture and accommodate larger rainfall events.
Sometimes referred to as infiltration basins, these systems are typically constructed as excavated trenches filled with stone aggregate that allow stormwater to percolate into the ground. Their effectiveness depends on sufficient depth to reach permeable soil and a solid understanding of the site's geology and groundwater conditions. Despite these requirements, they can be designed with a relatively small footprint, making them a practical solution for both residential and commercial applications.
Next technique is porous pavement. Porous pavement, this has been seen previously in our IDM. Porous pavement is a permeable surface which allows water to infiltrate into a permeable layer. We've updated this section with more general design criteria regarding the rate of flow and underlying system. The underlying system should have a minimum infiltration rate of 0.5 inches per hour, depending on the application and storage needs. The IDM provides additional details on the underlying layers and storage.
Permeable pavers are designed with small gaps between each unit, allowing water to pass through the surface into an underlying layer where it can either infiltrate into the soil or be directed into a pipe network. Commonly used in sidewalks, promenades, malls, and plazas, they can replace or enhance traditional paving to improve filtration and reduce runoff into stormwater systems. While this approach effectively expands a site's infiltration capacity, it is generally best suited for managing small rainfall events.
Our next technique is vegetative swales. Similar to infiltration trenches with long linear systems, a vegetated swale provides conveyance for larger runoffs in storm systems. These systems can be dry or wet and can provide stormwater quality and quantity control. This application is typically seen in large right-of-ways where slopes are greater than 3:1.
Vegetative swales are designed to slow down stormwater runoff by spreading it over a broad, planted area, allowing water to move gradually through the system. They are commonly installed alongside roads, parking lots, and other impervious surfaces, and can be adapted to fit within relatively narrow rights of way. Depending on site conditions and design goals, vegetated swells are typically classified into two types, dry swells and wet swells.
Next, we'll discuss green roofs and blue roofs. First, green roofs. Green roofs are vegetated roof systems. They consist of lightweight media to treat and drain rainwater. They can help slow runoff on a property and also reduce or offset underground storage needs. The thickness of the media layers can vary depending on the storage needs or the water quality needs.
A living roof or green roof incorporates a vegetated layer on top of a building to capture, filter, and temporarily store rainfall during precipitation events. These systems are made up of layered growing media, typically including a soil layer, a drainage layer, and an impermeable membrane to protect the structure. Because of this design, the roof must be engineered to support the added weight of soil, vegetation, and retained water.
Blue roofs, which are horizontal in design, are used to attenuate peak runoff. Detention volumes can vary, and roof designs will need to withstand live loads of properly waterproof. Blue roofs will need overflow systems to minimize load impact and typically best for smaller rainfall events.
A blue roof is a stormwater management system where rainwater is captured on the surface of a reinforced roof and then either allowed to evaporate, slowly released to reduce flood risk, or reused for non-potable purposes such as irrigation or toilet flushing. A key factor in designing the systems is ensuring the roof can meet necessary structural loading requirements to safely hold and control stored water. This approach is especially well suited for densely populated urban areas where limited ground space restricts the use of traditional vegetation-based or surface drainage solutions.
One of the most simplest applications of stormwater capture is rain barrels or cisterns. These features allow for storage of water, reuse, and depending on the size of the system, may allow for offset of underground storage.
As you can see in the images for details on various depths, these systems are typically installed in low-lying areas of a site where gravity can naturally convey stormwater, making them specially suitable for locations with a high water table. They are engineered as shallow, constructed wetland ecosystems designed to capture and treat stormwater runoff while also providing valuable habitat. Runoff first enters through a forebay, which helps trap sediment, and then flows through a series of treatment zones that slowly the water down and enhance filtration before it is released.
One of the largest GSI and LID techniques is constructed wetlands. Similar in concept to a detention basin of storing water, constructed wetlands provide the added benefit of stormwater quality. Constructed wetlands feature a forebay, permanent pool areas, hydraulic retention time to allow for sedimentation, and a mix of vegetation.
In the previous slide, I actually spoke about constructed wetlands instead of rain barrels, so I will go over the rain barrels at this time. So cistern systems are designed to capture runoff from building roofs and store it for later use, with storage capacities ranging from 55 gallons to several thousand gallons, depending on roof size and expected runoff, as well as intended use. The collected water is commonly reused for irrigation or vegetation, and in some cases can serve as gray water for building operations. Because cisterns store stormwater for future use, they help reduce overall water demand at a site while typically requiring minimal design, complexity, and maintenance.
Underground storage tanks, just as the name suggests, are underground systems designed to mitigate runoff, provide temporary storage, and slowly release into the ground. The key in this technique is to have good permeable soil surrounding the underground system. Geotechnical borings may be needed to verify soil conditions.
These systems consist of structured underground tanks designed to detain stormwater out of sight, storing it temporarily for later controlled release or reuse. After a storm event, the stored water is typically discharged into a downstream filtration BMP before entering natural waterways or surrounding soils, or it may be reused for non-potable purposes when water conservation is a priority. This approach is particularly effective for sites with large impervious surfaces and limited space for above-ground, low-impact development features.
Now we'll get into the GSI guidebook. So the recent update to the IDM promotes green stormwater infrastructure. A reference to the city's newly published Green Stormwater Infrastructure Guidebook was added to the IDM. Here's some additional details on the guidebook and keynotes.
So this guide can be found in the Houston Public Works website under Transportation and Drainage Operations and Stormwater Operations. So the purpose of the guidebook is identifying the GSI techniques that are specific to the Houston region and our specific needs. The intended users are planners, engineers, construction contractors, maintenance staff, and individual property owners. The guidebook is mapped out in a way that is easy to use for anyone and everyone. Chapter 1 outlines the guidebook purpose and how it can be applied when planning new projects. Chapter 2 outlines considerations for regional development and planning on a watershed scale. Chapter 3 includes site analysis of geology, hydrology, and climate to understand what BMPs, or best management practices, best fit the site characteristics. Chapter 4 provides an overview of benefits that can be found by incorporating GSI within sites. Last but not least, Chapter 5 details each BMP techniques, including components, site application, advantages, construction, and maintenance. All these techniques focus on regional solutions that work within the characteristics of the city of Houston, taking in account of Houston's soil and climate. With that, our section of the presentation concludes, and we can move on to Q&A. Alrighty, so the first question that we have is regarding porous pavers, any criteria for ongoing maintenance? Paresh, let me know if you want to take that question or if you want me to answer it.
I'll let you take that one. I know we have a lot of that in the guidebook, so go ahead.
Yes, sir. So per porous pavers and the criteria for ongoing maintenance go, we want to make sure it can be cleaned and that we have machinery to clean it. So that is something we are focusing on as this technique is being promoted throughout the city. So the second question that we have is, what design storm events must LID facilities meet within the right-of-way?
So these LID features are going to be similar to our storm sewer system. So in section 9.501C, the minimum of 2-year and a 1-hour storm event.
Wonderful. Next question that we have is bioswale design same as bioretention design requirements? Do you want me to take that
if
one,
you
sir?
could,
Okay.
yes. I know we
Yeah, of
have a whole
course.
section within the guidebook that goes really detailed in terms of the bioswale and the retention portion.
Yes. So yes, as far as the design requirement goes, they do overlap, and it can be used in such manner. So the next question that we have is, I'm actually not seeing the next questions. Let me pull it up again.
I think Tanzine, I might be able to help you here.
Thank you.
This is Luis. So gentlemen, where can I find the breakdowns and details for these LID techniques?
So the guidebook has a lot of the details and references up for the features, and the IDM specifically has all the implementation requirements needed in the chapter.
And chapter 5 specifically would, break everything down, every single section into the required details.
Great, thank you, Tanzine, for that additional context.
No problem.
So gentlemen, I also have a question here. What incentives can I get for using LID techniques?
So there is a new section within the Economic Development Department regarding tax abatements, and so that can be found on the Economic Development website under City of Houston. And so there's a whole criteria and a series of questions they have on there for tax abatements.
Great, thank you. Is there anyone else on the panel that has anything to add to that?
Yeah, this is Lam. So in addition to the tax abatement, as far as stormwater, as for permitting, there's one particular detention reduction. And so we can provide a detention reduction up to 0.15 acre feet per acre.
I'm not clear on the question then.
I think Lam was just adding an additional incentive that the
Sorry.
IDM allows for
Thank
detention.
you. I appreciate that.
Okay, as we're waiting for a couple other questions to roll in, I guess, gentlemen, I know y'all put a bunch of effort and TDO into creating this guidebook, and in reading through it, it's quite impressive. With the document looks great. The information that's there is quite informative. Was there anything surprising in working on that effort that really surprised you and that you'd like to shine a spotlight on? Can you provide your thoughts on that?
I can speak a little bit. Paresh, do you want to go first there, or?
Sure, I'll start. So I think
Okay, then I'll add.
part of the purpose of the guidebook is really looking at what type of features or techniques work well in Houston, and we have a lot of clay soils, and so something to highlight is when putting some of these features in, as I mentioned in one of the techniques, doing soil borings and testing the soil for permeability is a key feature, and so sometimes when adding these features in, looking at the soils is really important. Just to know the infiltration. Again, if you're trying to use that technique, or you'll need to use a pipe for conveyance as well. So Tanzim?
Yes, just to add on a little bit to that, is that the techniques when we were researching and when we were looking all over the country and even beyond that, we found a lot of neat techniques that several other communities used. So for us, we wanted to make sure whatever we do come up with is practical and actually can be used within the scope of what we're trying to achieve. So the techniques that we did come up with, we want to make sure they can be used sooner than later. So not coming up with anything that is too futuristic or anything like that. And we try to balance out between making sure they're easy to construct, but also easy to maintain, because we wanted to make sure on the back end for the next, whether it be 10, 20, or 30 years, these are actually maintained. So that is something we, heavily highlighted on throughout, or focused on throughout the creation of this guidebook.
Okay, thank you for that. We do have a new question that's come in. For systems that are intended to infiltrate into the soil, will a geotechnical report, I guess, need to be analyzed to show infiltration is possible based on the soil types?
Yes, there would be a certain geotechnical report that will be needed. But also the other thing to remember is some of the infiltration would be us putting in the topsoil. So even the soil beneath us may be clay, we may just put a pipe in there and put gravel and other soil on top. So at the end of the day, even if we are dealing with clay soils, we just want to make sure it's still permeable to a point where, it still helps out. If that answers the question.
Yeah, I think you got the main points there. I also, to add to that, I think the IDM has some requirements for infiltration rates on those soils. We assign a value to it. Does anyone else on the panel have any addition to add to that response?
Yeah, this is Lam. So our requirement, if you're not using an under drain system like Tanzim specified there, then the in situ soil must have a verified minimum of 0.5 inch per hour. Then you can infiltrate with your system.
Great, thank you for that information, Lam. I see another question's come in. Will this IDM be uploaded to the City of Houston website? I couldn't find the latest version. And gentlemen, I think I'll answer this question. We have uploaded it. We uploaded it at the beginning of March. And for this particular person that submitted this question, feel free to email us at our standard review committee inbox. We'll share the email address at the end of this presentation, and we'll try to help you to get to the right location on our website.
And Luis, to add to that, the GSI guidebook is on our TDO website, as mentioned earlier in the slide deck, so that is up.
Yes, sir. Thank you for pointing that out. Okay, thank you, gentlemen, for presenting this section of the presentation. It was quite insightful, and thank you for all your work on that GSI guidebook. The city would benefiting from that, your hard work in the future here.
All right, you're welcome. Thank you.
Thank you, everyone. Bye-bye.
Presenting the updates to the standard construction specifications is Christopher McCann. Take it away, Christopher.
Thank you, Luis. Good afternoon, everyone. My name is Christopher McCann. I work with the Design and Construction Standards Group here at the Office of the City Engineer as a supervising engineer. As Luis mentioned, I'll be reviewing the updates to the standard construction specifications that were included in this review cycle. The red line documents for the updated construction specifications can be found on the City of Houston Design and Construction Standards website under the Standards Review Committee tab. From here, you can navigate to the box sections, General Requirements and Standard Construction Specifications red lines from 2023 to 2026 review cycle identified in red for the current documents, and the 2022 to 2023 general requirements and standard construction specification red lines from the previous review cycle in red as well. The red line documents identify all the updated text within the specification in colored text. The final published documents for the updated standard construction specifications can also be found on the City of Houston Design and Construction Standards website under the Construction Specifications tab. From here, you can navigate to the box sections identified in red for the 2026 documents and also the previous versions from 2022 and also from 2023. These documents are divided into two files. One file contains Division 01 General Requirement Specifications, while the other contains Divisions 2 through 16 Standard Construction Specifications. There is no colored text within the body of these documents. However, changes within the document are noted with a vertical bar in the left margin. The current and previous specifications documents include a detailed page identifying the updates within the documents, as well as the sections that were the focus of our review cycle. These photos display all the updated standard specifications in 2026, 2023, and also in 2022. This new in the 2026 revision page identifies the standard specifications that are new, updated, and retired or deleted within the most recent updated version of the document. These are sections that include major updates to the specifications only. From this page, you can see that we did not have any new standard specifications and did not retire or delete any specifications. We did have technical updates to 25 standard specifications. On the following pages, I will get into some further details related to the updates that were completed. Several specifications had major updates that I will touch on both from Divisions 1 and Division 2. All major updated specifications are listed within the executive summary, but I'm going to present the most important modifications to these specifications here. Specification 01570 Stormwater Pollution Prevention Control includes an update to identify that repairing or replacing stormwater pollution prevention components are incidental to the bid items, regardless of the cause of damage. Specification 01740 Site Restoration includes updates related to standard and customized mailboxes, as well as measurement and payment updates for small diameter waterline construction and trenchless utility construction. Specification 02081, cast in place concrete manholes, has been updated to better define the resilient connectors and the requirements for storm sewer watertight and soil tight connection types. Additionally, the use of brick masonry for construction and mortar for storm connections has been prohibited. Specification 02082, precast concrete manholes, has been updated with the resilient connector definition as well, and connection types presented in the previous spec 02081. Additionally, within this specification, some third-party certification requirements for manufacturers, quality control requirements at job site delivery have also been updated. Specification 0221, removing existing pavements, structures, wood, and demolition debris, was updated under the measurement and payment section for removal of curb and gutter and existing pole foundations. In addition, the removal depth of existing pole foundations has also been updated. Specification 02317, excavation and backfill for utilities, has been updated with new minimum trench requirements and backfill and compaction requirements for thermoplastic pipe. Moving into specification 02400 tunnel shafts. This specification has been updated under the measurement and payment section to reflect partial payments more clearly and situations which result in a removal of shafts from the project scope of work. Specification 02445, jack and bore / jack and mine / pilot tube guided boring tunnels, has had the acceptance criteria requirements updated. Specification 02501, ductile iron pipe and fittings, has removed references within it to the utilization for storm sewers. Specification 02505, high density polyethylene HDPE solid and profile wall pipe, has been updated to further clarify soil tight and watertight joints and their requirements, material submittal requirements, manufacturer certification requirements, direct sunlight storage requirement, and some installation requirements, which include the disallowance of multi-barrel installations and inspection requirements during installation. The updates set forth in 02505 have also been captured within the specification 02510 polypropylene PP corrugated wall pipe. Specification 02533 acceptance testing for sanitary sewers has been updated to include pipe versus mandrel diameter requirements for polypropylene pipe. Specifications 02611 reinforced concrete pipe and 02612 precast reinforced concrete box sewers have both been updated with the third-party certification requirements for manufacturers and quality control requirements at job site delivery. Specification 02631 storm sewers has been updated to include the definition for local street, the submittal requirements related to thermoplastic pipe calculation submissions, storage of products in and out of direct sunlight, and updates to the use and cover requirements of thermoplastic pipe. Specification 02633, precast concrete inlets, head walls, and wing walls has been updated with further design loading criteria, third-party certification requirements, and finishing requirements for ring adjustments. This concludes the standard construction specifications portion of our presentation. Thank you for your attention. If you have further questions, please place them in the chat at this time, and we will make our best effort to answer them. Zainab, would you please take a moment to review the chat for any questions we may have received at this time?
Thank you, Christopher. This is Zainab Saheb. I'm project manager with the design and construction standard team. First, the question is, were there any guide specification updated during this review cycle?
That's a good question, Zainab. There were no guide specifications updated during the review cycle. The reason for this is because the guide specifications, they are maintained by the individual service lines within Houston Public Works, and they're not updated by the standard review committee.
Thank you. Second question is, for capital project, are the 2026 specifications required to be used if the 60% design submittal was submitted prior to March 2nd, 2026?
The short answer to this is yes. Per the general conditions document 00700, the most current specifications at the date of receipt of bids must be utilized regardless of the phase of design. A summary of this information that lays out those guidelines can also be found within the executive summary as well.
Here I see question, will the standard specification reference list be updated to reflect new updated specification? It looks like it was last updated in 2021.
It appears that this could be related to possibly the master unit price item lists. I'm speculating. The updated list that we've provided, I mean, the updated list would be like through the table of contents for the 2026 specifications. However, the master unit price list, if this is what we're referring to here, that is slated to be updated later this year.
Okay.
And I'd like to interject here on that, Christopher. Also, I just want to note that that master unit price item list is a reflection of the measurement and payment requirements in the specifications. And so as the city is working on updating that, really the engineers and contractors should be going by what's required in the specifications.
Thank you, Luis. Other question, where can I find a list of all specifications that were updated during this review cycle?
So the list of all the updated specs can be found within the executive summary. That document's included within the infrastructure and design manual, but it also is included at the beginning of the standard construction specifications document. The first few pages of that lay out all the notes that I made reference to before that show which details were added, which ones were deleted or retired, etc.
The other question, are there restrictions on using PP pipe under pavement driveways or major roadway? I think this is a question related.
Could you repeat that question, Zainab? Sorry.
Are there restrictions on using PP pipe under pavement driveways or major roadways?
Okay, that's a good question. So through the process that we've completed, we have lifted the restrictions on polypropylene pipe to where they can now be utilized under major roadways. You also said under driveways, correct? Yes, they can also be utilized within driveway culverts as well.
Christopher, I can also add into that response. So the IDM provides requirements on the minimum cover of those if you were to use thermoplastic pipes according to the location, whether it's under a major collector, thoroughfare, minor collectors, commercial driveways, residential driveways, etc. And that was part of what Lon presented earlier in this presentation. There are also some other requirements that are needed to be done to design and construct those, including consideration of buoyancy and pipe structural design according to AASHTO LRFD bridge design specifications, etc. And so please refer to the IDM for additional design requirements. And as Christopher stated, there are updates in our construction specifications for construction requirements.
Okay, thank you.
Thank you, Luis.
And there's a question related to IDM. Will this IDM be uploaded to the City of Houston website? I couldn't find the last version.
I think we previously discussed this, but yeah, the most recent IDM has been uploaded to the City of Houston website. If you are having trouble locating the most recent version, please reach out to us in the email that we provide at the end, and we can provide you specific direction how to find that document.
Okay. Thank you, Christopher, and we can move to the next section. Thanks.
Okay. Thank you again, Zainab. Thank you, Luis, for the assistance. In the event anyone is just joining us for this next section, once again, my name is Christopher McCann. I am here with the Design and Construction Standards Group, the Office of City Engineer. The next items that we're going to discuss are the standard details and the modifications we made during this review cycle. Similarly to the specifications, the red line versions for these updated standard details are found on the City of Houston Design and Construction Standards website under the Standard Review Committee tab. From here, you would navigate to the red box sections identified as standard details red lines from 2023 to 2026 review cycle for the current documents. And we also have the previous documents from 2022 to 2023 further below titled standard detailed red lines. These are also boxed in red as well. The red line documents identify all the updated text and images in the details located within red clouds. The standard details differ from the construction specifications in that the text is not colored. So there are only red clouds to indicate these modifications. And additionally, the red line document indicates new details with a watermark as well. The final published documents for the standard details are found on the City of Houston Design and Construction Standards website under the Standard Details tab. From there, you would navigate to the box section shown here for storm sewer details, since the majority of these details are what fell under this review cycle. Those are identified in red for all the directly related drawings to this review cycle. Please do note, though, that not all the details on our website have been updated, and in order to determine if a specific detail or document has been updated, the date on the title block of the drawing will refer to March 2nd, 2026. Selecting the Storm Sewer Details tab will lead to a display of the uploaded documents that you can see here pictured on the right as well. The standard details that have received updates can be found listed within the first few pages of the standard specifications document, and also within the executive summary document that was previously mentioned that has been included with the infrastructure design manual. As shown boxed in red here, this provides lists of new standard details updated, and standard details retired or deleted. All of these new and updated standards will display that published date of March 2nd, 2026 within the title block. To provide a summary, what was completed during this review cycle, we created 13 new standard details. We retired 9 standard details, and we had 22 total standard details that included technical updates. Multiple standard details were additionally either renumbered or retitled. This was completed in order to allow the details to align more appropriately with their reference construction specification numbers and to further clarify the specificity of each detail. Within the new 2026 revision document shown on the previous page, it lists the new standard detail number with the previous number located within parentheses for the numbers that have been modified. We also separated several drawings that contain multiple details on one drawing. A previous example of this is shown to the right. In addition to these updates, we've also updated the title blocks and provided the DWG formatted files available for download from our website. The next few slides will discuss the new standard details that have been created. Many of the updates completely revolved around new frame and grate, cover details, and new inlet details. Detail 02082-14, precast concrete top slab lid, was created for the purpose of having a universal slab lid for multiple iterations of styles for inlets and manholes. Detail 02090-03, 32-inch storm sewer manhole frame and grate is a frame that can be utilized in both a standard orientation and also an inverted orientation. Detail 02090-13, 30-inch storm sewer manhole frame and hinge cover is a new detail that provides a latched cover that can be utilized in storm surge situations for venting. Detail 02091-02, storm sewer non-metallic manhole frame and cover, depicts a composite manhole as opposed to the more traditional cast iron versions. Detail 02317-10G, storm sewer bedding and backfill for thermoplastic pipe in dry, stable trench, was created to provide a more specific detail associated with the backfill requirements for thermoplastic pipe. Details 02633-01 through 02633-04 are for the respective types A through D inlet iterations. Details 02771-03 and 02771-04. Curb and gutter transitions provide details for the transitions surrounding precast inlets associated with types B and C iterations. The slide here provides a few examples of our new standard details that have been created for a quick look. We have the thermoplastic pipe bedding and backfill, the composite manhole cover, an example of our storm sewer frame and cover, and then also the curb and gutter transitions for reference. The full list of retired standard details is provided here. At times, details are retired when they are notably no longer being utilized on construction projects, or construction specifications have been updated, to no longer allow specific circumstances such as the use of brick masonry. As it relates to the storm sewer inlet details mentioned above, many of these were retired and newer versions were created to align with industry and construction standards. This here is a depiction of a few details that have been retired. Again, you can see here that the multiple details were previously included on one drawing. Many details similar to the configurations above have become their own separate details. As previously stated, these details were also renumbered in many cases. The examples above display a reference to specification 02632, cast in place inlets, head walls, and wing walls. Drawings such as these were more appropriately retitled under specification 02633, precast concrete inlets, head walls, and wing walls. I will next discuss our existing standard details that include technical updates to the drawings. The list above includes predominantly updates to inlet and manhole details. Details 02082-13, storm sewer precast box inlet manhole, shown to the right, included updates to the wall thickness requirements based on maximum depth of the base unit. Details 02082-15, -16, and -17 include drawings for proposed manhole additions on existing conditions. Details included under specification 02090 are for storm sewer grate and cover assemblies related to frames, grates, rings, and covers. These details have been further updated to provide additional technical data related to weights and casting requirements, identification marking requirements, and references to other details for maintenance purposes. Details included within specification 02317 include updates related to the excavation and backfill for utilities. The updates to these details mainly pertain to updating notes that make reference to other standard details and construction specifications. Clarifications have also been made within notes for the direction related to the use of thermoplastic pipe. Details included within specification 02632 include items associated with cast-in-place inlets, head walls, and wing walls. These updates revolve primarily around reinforcing steel references and callouts on inlet drawings to provide further clarity. Detail 02754-02, driveways with culverts on open ditch type streets is shown to the right. This detail has been further updated to establish clearer instruction for the appropriate measures for exposed pipes, minimum cover requirements, and further references related to thermoplastic pipe. I believe this brings us to the end of the standard details portion of our presentation. Thank you again, everybody, for your continued attention. If you do have further questions, please input them into the chat and we will have a look at those. Zainab, if you have a few questions you can have a look at, please. I'd be grateful. Thank you.
We received a few questions. First question, should mailer submittals for capital projects include the 2026 standard details?
So just to clarify, you did ask, should the Mylar submittals for capital projects include the 2026 standard details? Is that correct?
That's correct.
Okay. So the 2026 standard details were made effective as of March 2nd, 2026. Phase 2 final design projects that have been submitted prior to March 2nd, 2026 are recommended that all designers make an effort to incorporate the new changes into their current design to the extent that it does not increase costs or negatively affect the project schedule. If you were to revisit the executive summary document, the executive summary lays out all the expectations and requirements for the utilization of the new standard details, the new IDM, and also the new specifications.
The other question, what is the reason for renumbering or renaming the standard details, and how can I find the renumbered, renamed details?
Okay, this is a good question. I think we touched on it a little bit previously, but majority of the time when the standard details are either renumbered or renamed, it's to better align with our construction specifications and to provide long-term clarity to the association of each specific detail in order for us to make it less effort for them to be more easily located. As for a list of these standard detail documents, within our website, we do have a 2026 list of standard details document. This can be found on the Design and Construction Standards website. If you scroll to the standard details tab within there, this document will provide the previous name and the detail number for all details, not just details included within this review cycle. And then it also provides the updated name and number. And in addition to all of that, it includes the effective date for all standard details. So if you were to review this document and find the date March 2nd, 2026, that would be an indication that this document was updated within this past review cycle.
The other question, have the updated CAD files for standard details been published?
The updated CAD files, have they been published? Yes. So we have updated our website with the CAD files. And to further elaborate on this, we do not have all the files available in DWG format for all of our standard details. We are making an effort to update these as we move through our next review cycles in the future. We intend to update these files as we continue to release them during these review cycle publishings.
Thank you, Christopher. That was the last question I have.
Thank you, Zainab. I guess, Christopher, I know we're trying to stay on schedule here. I guess while we wait for more questions to come in, I guess I can ask you a couple of questions as well. I know that you mentioned that the city now for concrete products will require a third-party certification. Did that apply to both inlets and manholes, or was that just one of those two type of structures?
That's a good question. No, that specific requirement is spread through the manhole inlets, precast requirements. So yes, to answer your question, yes, it is both for manholes and for inlets as well.
Yeah, thank you for that. I know that we made a few modifications to, and I guess improvements or changes to our thermoplastic pipe specifications. I think at one point the city wasn't allowing them to be placed in direct sunlight. Has the city updated that requirement?
The city has updated that requirement. We are basing our decision on the manufacturer recommendations. So if the way it's stated within our specification is to keep them out of direct sunlight unless there's manufacturer recommendations that allow that product to be stored within sunlight.
Thank you. Thank you for that information and clarification. I know that that was a one that we went back and forth with during this review cycle. Okay, so I guess in that time frame we didn't receive any more questions on the drawings. So I'll move on to the next section. Thank you very much, Christopher.
Thank you, Luis.
Okay, so thank you, everyone. So we're now at the closing of this webinar. To recap from the beginning of the webinar, June 1st, 2026 is the effective date of the new design criteria. For private public sector projects, you must submit your substantially complete plans prior to this deadline to be grandfathered under the 2023 requirements. For additional background, refer to the 2026 IDM announcement and IDM executive summary. The IDM summary is provided at the beginning of the IDM document and gives implementation information for the IDM, standard specifications, and standard details. Before we proceed to the final Q&A, I'd like to discuss the upcoming 2026-27 review cycle. August 2025 was the beginning of the new review cycle. The 2026-2027 review cycle will cover Chapter 6, Utility Locations, Chapter 10, Street Paving Design Requirements, and Chapter 12, Street Cut Requirements, along with its related specifications and standard details. This year's open comment period was from August 22nd, 2026 through November 30th of 2026. Both the public and the city employees were able to submit comments and proposals to our existing documents. The comment period is actually now closed. It closed in November 30th, 2025, last year. I apologize for that. The 2027 IDM publication is currently estimated to be July 1st, 2027. And now I'll open it up to additional questions for any of the sections and content that was presented today. Please type them in the chat. And I believe I have some here that were asked previously that we may be able to get to. And so I think this question was directed to OC Storm. I think Lam, you might be able to answer this question. There's a question, can you confirm the minimum detention requirements for LID incentives, I believe was the question. Could you give some more context on that?
Yeah, sure. So under the IDM Article 9.603 LID incentives. So for detention criteria 3, which is a minimum of 0.8 acre-feet per acre. So if your detention reduction is granted, the 0.15 acre-feet per acre reduction is granted, then your new required detention is lowered to 0.65 acre-feet per acre.
Great, thank you. And also, I think there's a question here that may be answered well by Hussein. And Hussein, there was a question if we could confirm the previous I value of 0.27 inches per hour. Would you like to give some a response or context to that requirement?
Okay, I see two questions. I mean, about talking about new rainfall rate for the stormwater quality volume and treatment. So right now we change that intensity 0.27 to 1 inch per 1 inch per hour. So bottom line is minimum 1 inch storm depths and minimum design intensity of 1 inch per hour are flat minimum numbers for new development and redevelopment. So no difference between those two development. That's it.
Okay, thank you, Hussein. Thank you for that response. There's another question that we had in this presentation, seemed to be related to how does storage for rain barrels interact with other requirements, I believe. I guess, Lam, could you give some additional background on the question and provide a response if you have one?
Yeah, I believe this is based on the LID technique. So related to rain barrels or any above ground system or tanks, our table 9.11 LID techniques in the IDM page 9-90, it'll specify the restrictor design requirement for the drain time.
Great, thank you for that response.
There's a question regarding, I received now regarding the details. The question is, I have downloaded the DWG format of the standard details. How do I know which size data block I should utilize?
Great, Zainab, would you like to answer that question?
Oh, sure. In the DWG file, the layout tab usually is named per the size of the details. If we go to the layout at the left corner, usually there is the sheet size. In our standard details, we put all sheet sizes there. So as an example, if the tab read or labeled 11 by 17, this means the block should be 11 by 17.
Great for that. Thank you for that information. I think also, Zainab, we're working on an update to one of our references that gives additional guidance on the sizes. Is that correct?
Correct. Soon we will publish the size of all sheets, detailed
Great,
sheet size. Yeah.
Great, thank you for that. We had another question here. I think this is directed to possibly Christopher McCann. Were there other standard details updated that were not a part of this review cycle? Christopher?
Yeah, that's a good question, Luis. So yes, there were. We had two standards that they are shared standards between sanitary work and storm sewer work, located within the 02317 specification details. So these both were updated as well. And to refer back to what I was saying earlier, if there's any doubt as to what the most recent effective date is of a standard detail, always refer back to the list of standard details that is published, because we have updated that. As we updated the storm sewer details, we ensured that we were updating the entire document as a whole. So we will make any other updates to the remaining details as well in there.
Okay, thank you, Christopher.
Luis, I received one question regarding the details. Is about this review cycle. The only update is regarding only storm sewer details, or there are other updating in other sections.
Okay, I guess Christopher, Zainab, if either one of y'all, if you'd like to respond to that question.
If you like, Christopher, I can respond to this question.
Go right ahead, Zainab.
Okay, there are two sections affected by this review cycle, which is wastewater details. The number of the detail is 2317-02, 2317-03. And by the way, these details also shared with the storm sewer. And the other one is in section street paving and sidewalk details. We have details shared also the storm sewer, which is detail 2631-GD01, and the old number for these details, because also we updated the detail number. Now the new, the old number was 2362-11. And there's also detail 2754-02, which is a driveway with culvert and open ditch type street. So these details are also updated in this review cycle.
Great, thank you, Zainab, for that additional information. And so, thank you for all of your questions. If we did not address your questions from this webinar today, we will respond to it on our website. And we've reached the end of the webinar. If you have additional questions, feel free to send them to the Design and Construction Standards inbox. It's listed here on this slide. We will be posting a recording of this webinar a few days after this event. Go to our website, use the IDM tab and scroll down to the video links. They will be posted under the IDM webinar heading. On our website, we will also post responses to the questions we weren't able to get to in this webinar. Thank you again for joining us today, and we wish you the best.